So up to this point we've talked about intrinsic or pure semiconductors, but for the next few videos we're going to be talking about extrinsic semiconductors. And so we're going to see in a little bit that we can achieve extrinsic semiconductors by a process called doping. And so as I've written here, essentially the problem is that our charge carrier concentrations in intrinsic semiconductors are just too small to be useful. And so we saw that in the previous video where we said our silicon concentration was on the order of 10 to the 22nd per cubic centimeter, whereas our free carriers at room temperature, so these are our electrons and our holes, the concentration is on the order of 10 to the 10th per cubic centimeter. So it's not really enough compared to this concentration of silicon. So we have this process called doping where we can increase these available charge carriers. And not only can we increase them, we can increase them to a certain level so we can sort of control the material properties. And so before we get into how we can use that to create devices, let's start by more clearly defining what doping is. So of course we're not talking about doping in terms of athletics. We're not shooting up steroids into our semiconductors, but what we're doing is we're creating substitutional impurities. So substitutional impurities. And so what these substitutional impurities are doing, we're going to see a little bit more clearly in the next two videos, but these substitutional impurities are going to make it such that we have only electrons created, and these are free electrons, or only holes created. And so let me just add in here, these are free electrons. And so what that means is that previously we said that every time we create an electron, we create a hole, so we have these electron-hole pairs, but with this doping, we can only create one type at a time, and so that's going to be useful as we create devices. Now, if we're talking about silicon, so for silicon, and so actually let me come down here to our periodic table. So I've copied this again. So we've got our periodic table. So for silicon, remember our silicon is here in what we called earlier this group 4. And so because it's in group 4, we're going to have dopants from either group on either side. So dopants from group 3 over here on the left, and the one that we're going to look at, a common one, is boron. Or we could also have dopants from group 5. So group 5 over here on the right. And so a common one that we're going to look at is phosphorus. But again, we'll see why this idea is, but just sort of keep in mind sort of this underlying chemistry and how it relates to our valence electrons as we go through the next couple videos.